Hey, what's going on everyone? In this video, I just want to go over the Arrhenius equation and the CME43 or the cumulative equivalent minute 43 equation and how they're used in the COMSOL video tutorial series. So the Arrhenius equation is defined as omega as a function of time is equal to the integral from 0 to tau. A is a frequency parameter. As a unit has 1 over s, and times minus the activation energy divided by the universal gas constant times the temperature, and this can be a function of time. And you integrate this with respect to time. So this part is what they call the rate, reaction rate K here, and you integrate that and you get a dimensionless value omega, which is useful to find damage. So let's say once you have omega, you want to find percent of cell damage. You write 1 minus e to the minus omega. Easy as that. So we're going to use this in our COMSOL to basically look at various cells. Usually on a table they give you the value for A and EA, so that will change the different responses for different cells. The next part I want to talk about is the CEM43, and that is defined as the integral from 0 to t to r CEM raised to the t break. That's the breaking point temperature minus T2, and you integrate that with respect to time. So let me explain what's going on here. So basically, the CEM43 tells you that, at the temperature other than the breaking point temperature, you can expect to have the same damage if you had done it at 43 degrees Celsius for this duration that you have to estimate. For example, let's say you have a process where you heat something at 50 degrees Celsius for 1 minute. This is just an example, just arbitrary. So the CEM43 means that you would compare it to a 43 degrees Celsius process, and the CEM43 value will tell you how long that would take to get the same equivalent damage as the one at 50 degrees Celsius. Say, 128 minutes or something. Depends on the R value you have and the temperature that you use. But let me go ahead and explain what the heck this is. This is very important. RCEM is defined as e to the minus activation divided by R times T1 plus 1. T1 is the same thing as T break, the breaking point of the cell. So usually it's defined as usually it's at 43 degrees Celsius, and this temperature you have to put in kelvins, not Celsius. You need to convert that to Kelvin. Okay. And once you have these, the CEM, you can find the damage. Basically, now remember this is a constant temperature comparison for at 43. So the damage equation becomes just a function of time now, where you have a constant temperature, so it makes it really easy. It becomes E minus EA RT. This is constant. The temperature is now constant at 43 times however long the CEM is. So this, whoops, not that, T tau CEM equals to this right here. So once you find the number of minutes that's equivalent to the process at whatever temperature you're using, you just multiply with this at 43 degrees Celsius, and you find the damage by just, as we've done before, percent damage 1 minus e to the minus omega. Alright, so in COMSOL, that's what I try to do. I basically compare the two damage predictions. Something go like this, and the other one, you know, would track it or not track it, overestimate or underestimate it. So, for example, you have a process going like that, that's optimistic about the cell death damage, percent damage, here on the y-axis, and this is time. This will be, you know, CEM prediction, and this one is Arrhenius prediction. Alright, so this is just a quick overview of what's going on behind the curtain, if you will, for COMSOL. And I hope you guys enjoy this video, ask questions, and if needed I'll make more videos explaining the math behind this, but this is the basic equation that we're going to use for the PDE modules in COMSOL to solve for CEM and Arrhenius cell death predictions. Alright, thanks for watching. I'll see you in the other videos.